In this lesson, we'll be looking at some more C# basics that we'll be using throughout this course. We've already covered a lot of basics in the last lesson, such as data types, operators, classes, and more. But as we pointed out to ourselves at the end, the two most important things we learned about were variables and functions. The two functions we looked at were the start and update functions, which we know are two functions that Unity provides for us that trigger themselves to run depending on the frames of our game. So we'll be starting this lesson off by learning about how we can create our own functions and how we can use them. Okay, so if you haven't yet got your script open from the last lesson, go ahead and open it up again now. Remember, we saved it within our scripts folder under the My Scripts folder we created ourselves, and we called it Practice Script. Once we've got our script open, we can start this lesson by creating our own custom function by following the same structure as the start and update functions. Now we can call our new function whatever we want. I'm simply going to call mine new function. So I'm going to write void my new function. Then I'm going to add two brackets at the end, followed by two curly brackets to create a body. Now make sure that the names of your functions start with a capital letter, by the way, or else they're not going to work. Now, unlike the functions that we looked at in the last lesson, our custom functions don't have any way of being triggered on their own. However, we can trigger them by calling them from within another function. To do this, we simply choose a function, for example, let's say the update function, write the name of the function we want to call to activate, and write it out in a similar way that we reference our variables. So inside the update function, I'm going to write my new function. The only difference is that when we want to call a function, we have to include the brackets at the end of it again before the semicolon, just like that. So now, every time a frame is run in our game, anything inside of the update function, and by extension, the function we called my new function, will be called. This is similar to what we did in the last lesson with the debug.log function. Despite the fact that it is its own function, called from within another script, by referencing it in our start or update function, we can trigger it to run. Now, what if we wanted to do something within our function, but only if a certain condition is met? Let's say hypothetically that in our game, only when the player reaches a certain speed, we want to give them a health boost. Well, we can use what's called an if statement by putting if with two brackets next to it to do this. Now, inside the brackets of an if statement is where you create your condition or what you want to check for, which in our case is the speed of our speed variable, before we then go on to perform specific behavior, which for us is to boost the health. Now let's say that we want to give the player the health boost when their speed becomes 100. We would then compare whatever value our speed is currently at when this function is called by adding two equal signs and the number 100 after it. Now, unlike how one equals sign sets the value of a variable, two of them together are known as a type of comparator used to compare one value or variable to another. So by writing this, we are asking our code to check or compare and see if the speed variable ever becomes equal to 100. Now, if it does, I personally want the health to increase by 1. So underneath the if statement, I could write health equals health plus 1. But a simpler and quicker way to increase or decrease an integer variable by 1 is to either add two plus signs or two minus signs respectively following its name. So in our case, I'm instead going to write health plus plus semicolon. So now, if the speed is ever equal to 100, the value of our health variable will be increased by 1. Now we can tell this is what will happen once the if statement is called, as our text has been indented to the right slightly automatically. So let's check to see if this has worked by taking the debug.log value that we originally put within our start function, pressing Ctrl X or Command X to cut the line of code, and then pasting it in our new function with Ctrl V or Command V. Let's also quickly comment out the debug.log function in our update function, as we won't be using that anymore. The last thing we want to do is make sure that the speed variable will in fact equal 100 exactly at some point. Right now we're starting with a value of 0.5 and adding 1.2 to it every frame, which will not equal 100. So to make sure it does, let's change the value 1.2 to 0.5. Finally, we can save our script. Now that we've saved, let's jump into Unity and let's open up our console tab once our script is finished compiling, as this will be where we will monitor the value of our speed variable. Now, some of you may find this warning message inside your console tab. The message reads, "There are inconsistent line endings in the script that we've just edited." Now don't worry if this has popped up for you, it's not a game-breaking issue and it's a very easy thing to fix. Simply go back into Visual Studio and in the top left corner, close the script that you were just editing, then go back into Unity, go back to the Project tab and open up the script again. You should then be shown a window like this, asking if you'd like to normalize the line endings in the following file, the file we've just opened. Simply click yes, save your script one more time, jump back into Unity, wait for the script to compile, and you should be good to go. The only thing left to do now is to reopen the console tab and remove this message we were shown earlier. And now we can play our game. Remember, we want to watch our console tab to see if the health variable changes from 10, the value we set it to within our start function, to 11. So it starts at 10 and there you go, it changes to 11. Once you've done that, you can end your game and jump back into your script. Okay, so let's quickly go back to our comparator, the double equals sign, as it's not the only one we can use. We could check to see if a value is greater than or less than another by using the same symbols we would in a maths equation. So let's change our statement to check to see if our speed variable ever becomes greater than 100 by adding the appropriate symbol for it. If we wanted to, we could also include an equals symbol after it to check to see if the speed is both equal to or greater than 100. But for this example, I'll just be using the greater than symbol. I'm also going to change our statement so that our log function is called within the if statement alongside the increase in health. Earlier, we were able to tell our script to increase the health variable by 1 by writing it directly under the if statement because we were only telling our if statement to do one thing if its condition was met. But now that we want to tell it to do two things, we're going to need to include two curly brackets and give the if statement a body, just like we do with our functions and classes. Then all we need to do is cut the lines of code that we would like our if statement to perform and paste them inside of the body, just like that. We could then quickly tidy up our script a little bit by removing the empty spaces. Save it and jump back into Unity to test it one more time. So this time we're expecting to see the console tab display the value of our health only after the speed variable has been increased enough until it is greater than 100. So let's press play and see what happens. So first of all we see nothing, and then finally we see the health increase, and it increases by 1 each frame now that the speed is greater than 100. Great, so let's jump back into our script and move along. Now we can also use logical operators, which allow us to check for multiple conditions before our if statement runs any of the instructions that we give it, as well as run them if the opposite of our condition is achieved. The first two operators are simple ways of saying the words and as well as or in our if statement. But before we can create them, let's quickly scroll to the top of our script and re-enable the player is grounded Boolean variable, as we'll be using that as our second condition. So now we can check to see if either the speed is greater than 100 or if the player is grounded Boolean is equal to true, which we can do that by adding two vertical lines in between the two conditions. What's good about checking booleans within if statements is that we only need to write its name and our code will read that as if we were asking it to check to see if the player is grounded boolean was ever equal to true. You could of course write player is grounded equals true, but I'm just going to leave mine with just the name for simplicity. So now only one of these conditions has to be true for our if statement to trigger and give our player a health boost. However, if we replace the two vertical lines with two ampersand symbols, we're telling our code if the speed is greater than 100 and if player is grounded is equal to true, only then do we want you to increase the health of the player by 1 and show us this in the console tab. So unlike before, where only one condition needed to be true, they now both must be true for our code to execute our instructions. If we wanted to, we could use multiple logical operators to check as many conditions as we wanted to, but for now, we'll leave our script as it is. The other operator we could use is the exclamation mark to see if a condition is not whatever we compare it to. So if I now put an exclamation mark in front of our boolean, we'll be checking to see if both the speed is greater than 100 and if the player is grounded boolean is false rather than true. The last thing we'll talk about when it comes to if statements is how to check for an alternative condition. We can follow our if statement with an else if statement, just like this. Now this is our way of saying to our code, if the conditions in our first if statement were not met or didn't happen, only then do we want you to check the conditions inside the else if statement. And if they are true, then you can perform the behavior we tell you to in that statement. We could also write, following either of those, an else statement. Now an else statement will check to see if the conditions within the if statement and the else if statement were not met. And if they are not, then it will do whatever we tell it to within its body. Now, because we've already set our conditions in our if statement and else if statement, if we were to use it, we don't need to repeat them in the else statement, and thus we don't need any brackets next to it. So let's test these by changing a few things within our function. First, let's remove the boolean from our if statement, just to make things a little clearer. We'll also scroll to the top of our script and just comment out the variable as we won't be using it anymore. Let's also tell our code that we would like to -1 from our health and also include the debug.log function to check the health's value and remove it from within our if statement, so that now if the condition of the if statement is not met, we will see our health decrease in our console tab. So let's save our script and check it out in Unity. So what we should expect to see in the console tab is our health lowering by 1 value each frame until our speed is then greater than 100. Once that happens, we should stop seeing our health reduce. So let's play the game and see what happens. So our health value drops and then stops because now the speed is greater than 100. Okay, so let's jump back into our script and let's now take a look at access modifiers. Now if we take ourselves right back to the beginning of the script where we talked about our main class, the word public that precedes the rest of our class is an example of an access modifier. They are used to tell other classes what information can and can't be accessed if we ever wanted to pass data between them. If the word public, for example, is ever found before a variable, a function, or a class, it will allow the information within it to be accessed by other classes anywhere within Unity. If, for example, we wanted another class in this script, or even a different script, to be able to access the health variable, we would include the access modifier public in front of our data type. By doing this, we can also view and change that variable within the Inspector tab in Unity. The health variable has now become what's called a serialized field. So if we save our script and move over to Unity, once the script has compiled, let's select our game object, and we should be able to see that the variable health has appeared on our practice script component on our game object. Now, if we needed a lot of public variables to be accessed by other classes, but didn't need all of them serialized, we could go back into our script and right within squared brackets in front of the variable, hide in inspector. This is an example of what's known as an attribute, a way of adding additional behavior to a variable. We can tell that this is an attribute thanks to the squared brackets at the beginning and at the end. And in this case, they can be really handy for keeping our scripts in Unity organized and clean. You may also sometimes see them written above variables like this. Either way, our script will still recognize that we're using the hide in inspector attribute for the health variable. So it's up to you where you write it. Now, the next access modifier is called private, and it does the exact opposite of the public modifier. Now, any variables, functions, or subclasses labeled private cannot be referenced, accessed, or called upon by another class. Only the class that they were created in can use them. Now, this is a great way of protecting functions and variables from being unintentionally used by yourself or another programmer from within other classes, and, like the public modifier, good for clearly labeling the information in your scripts so you know how they'll be used. Usually, unless we know for a fact we will be using something in another class, we label most things private to protect them. Also, if a variable is labeled private, it won't be serialized in the Inspector tab, but we can change this by writing another attribute in front of it, serialize field. If we then save our script and jump back into Unity, wait for our script to compile, we can then see that the health variable has disappeared because we've hidden it using hide in inspector, but the speed variable has appeared because we've serialized the variable. Now, there is one more main modifier called protected, as well as a few others. Protected works as a kind of hybrid between public and private. Now, we won't be using this modifier too much in this course, but I will have a link underneath this lesson which will take you to a page to learn more about it. And that's all you really need to know about access modifiers for now. By far, the most common two are private and public, which are the two we'll be using a lot more of later on in this course. And with that, we're now well equipped to start creating and editing basic scripts. Now that we know how to create our own functions, we can use them later on with our audio. We'll be able to create our own functions for performing different and unique tasks for the various types of audio that we'll be playing. We've also looked at how we can use if statements to only execute an action if a certain condition is met, as well as the difference between the main access modifiers that we'll be using the most. Now, if statements are going to be very common as we move on because they allow us to set conditions and criteria to check for before our audio is played back or manipulated in some way for our player to hear. Now, before we move on to the next lesson, feel free to create your own scripts, to write your own code in and learn more about what you can do and can't do with these new tools at your disposal. But once you've done that, feel free to pop on over to the next lesson. Thanks for watching this one, and I will see you there.